Okay, so question 14, it seemed like a few people were struggling with. Let's just snap this one here. Okay, and they say, find the lower and upper bounds of the perimeter of an equilateral triangle with area 100 centimeters squared measured to the nearest 10 centimeters. Okay, so we can easily find the upper and lower bound of the area. That's not what they're asking for, but we will need to use that. So we will need to use this information here, upper bound, so the area 100 centimeters squared means, of course, that the lower bound for the area is 95 and the upper bound for the area is 105. The problem that we have is that we don't have a formula for the area of an equilateral triangle. So that's the first thing that we need to develop in this question. Now, obviously, you could get on Google and you could ask what's the formula for the area of an equilateral triangle, but you can also create it. It's not too difficult. So that's what I'm going to do to start off with. So equilateral triangle, let's draw one over here, and they've all got side length of x. So all of these ones have got x on the side. Now, to find the area, we need to do the base times the height. So we're kind of missing this. We need some sort of expression for that before we can develop the expression for the total area. So I'm going to draw another diagram here because I realize that one's not quite good enough. So this one's got half x at the bottom. This is x here. And you can see that we've got a right angle triangle here. So we can use a squared plus b squared equals c squared. Okay, well, this is actually our height. Let's call it our height. So a, or half x, is a associates with h, or a associates with half x. I'm not sure which one, but it doesn't really matter. So we've got h squared plus, in brackets, a half x squared equals c squared, which is x squared. Okay, so we've got h squared plus, it's going to be plus a quarter x squared. We do a half x times a half x. But I'm going to take that off the other side and save myself a little bit of writing out here. Normally in the book, I would write that down on the board. And if I take a quarter x squared off x squared, I get 3/4 of x squared. So that's just me multiplying out the brackets and taking it to the other side. So we've got 1x squared, take away a quarter x squared, gives us 3/4 x squared. Okay, so now h is equal to the square root of this thing. Well, square root of 3/4, we can split that into two square roots, two surds. We get the square root of 3, and the square root of 4 is 2. But we don't know what the square root of 3 is, of course. And the square root of x squared is x. And we don't need to worry about plus or minus there, because we know that the height is going to be positive. So it's just square root of 3/2x. Okay, now we're able to come up with a formula for the area. So the area is equal to the base. So half, oh, what am I doing? Not a half x. We want the full base of this equilateral triangle. So in fact, x multiplied by root 3/2x, so that's the height. And then we want to divide that by 2, which is the same as timesing it by a half. So I'm just going to put that half on the front. That's half base times height. Okay, so then we can simplify this one. X times x is x squared, square root of 3 on the top, and 2 times 2 on the bottom, which is 4. Right, so there's our area. Okay, well, now we know that the area is either, so maybe we should come up with a little table for ourselves. We've got area is lower bound. So lower bound is 95. That's plus or minus a half of the thing that it's been rounded off to. And upper bound is going to be 105. Okay, so we're going to now set A. So we've got A equals root 3/4x squared. And that's equal to 95, or a is equal to the square root of 3 over 4 x squared equals to 105. Okay, well, I've done my little bit of working out to the side here. So if we if we divide by the square root of 3 over 4, we're going to get 219.39 dot dot dot. Okay, so there's our x squared. So x is the square root of that. And again, we don't need to worry about the negative square root because we know x is going to be positive. 14.81192 something or other. And then 3x, because we're interested in the perimeter. So let's just recap. This 14.8119, if you go backwards, that's going to give you the area once we square it in terms of by the square root of 3 over 4, 95. So 95 is the smallest area that was possibly recorded, and that comes from starting with an x value of 14.811. Okay, now 3x uses that smallest possible x value to give us the perimeter. So the perimeter in this case is 44.343 something like that. So I'm just going to say 44.4 because I've rounded that off to 3 significant figures, which would be standard in providing a final answer. Okay, if you do exactly the same thing in this case, you should get x is equal to, I'm just going to skip a step here, okay, to make it simpler, 15.5719 something. Okay, so 3x, or your perimeter, is equal to 46.715, or again, we can simplify this one, 46.7 centimeters to 3 significant figures. Okay, we should say accuracy used there as well. Now that's 3 significant figures at the end to answer the question. Find the lower and upper bounds of the perimeter. If we wanted those as accurately as possible, then we'd leave all those decimal places. Guys, thank you for listening. That's a really tough question there. That would be like a level 8 or 9 question on a final GCSE paper. Okay, thanks then, guys, and I'll see you tomorrow.